Welcome to today's webcast, brought to you by Datavale. I'm Stephen Fegg, Business Development Manager at Unisphere Research and Database Trends and Applications. I will be the host for today's broadcast. Our presentation today is titled, Tuning ETLs for Better BI. Before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We will try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if you've won. Now to introduce our speaker for today, Chuck Ezell, Performance Tuning and Optimization Services at Datavale. For more information on our speaker today, you can click on the speaker's icon at the bottom of your console. Now I'm going to pass the event over to Chuck.
Thank you, Stephen. Welcome to our presentation. This, I hope, will be informative. I hope that the time we spend together today will be educational. I hope also that this will give you an opportunity to maybe take a look at some of the ETLs that you have running, and maybe some tidbits that I share today might provide some insight into ways that you can look for bottlenecks and other problems in your environment. So let's begin. Very quickly, I just want to mention some of the things we're going to discuss, just to kind of the lay of the land and some of the items that we want to present today. I'm going to spend just a few minutes talking about the differences between OLTP and OLAP, and how that they're just a very quick overview of that, and then why they're different in the approach for tuning. And then we're going to peel back all of the layers and the components and the pieces and parts of an ETL, talk about some of the points of failure, and then I want to dig a little deeper. I'm going to circle back, dig a little deeper into the source, transformation, and target of a particular ETL, and then talk about some tuning points, some things that we've learned in some of the tuning activities that we've done with the ETLs and ELTs, and then some common failures that we've seen, some things that we've encountered in some of the ETLs that we've tuned, and then some misconceptions or some ideas that maybe we can kind of discuss a little bit and hopefully kind of eliminate some misconceptions and ideas that people have about some approaches and things that can be done with ETLs. And then, of course, we'll just spend the last few minutes talking about some questions and just do a recap. So the differences between OLTP and OLAP. So OLTP is online transaction processing, and you no doubt you have an OLTP database, at least one, if not many in your at your company, in your environment. So it's typically a relational database, an EBS database, for example. It is a database that has many tables. Those tables are relational. And the emphasis for an OLTP system really is fast querying and maintaining the data integrity between your relationships of the tables. So you're going to find foreign key relationships. You're going to find a lot of data that's normalized, sometimes down to the third norm. So the data itself is, you're going to find very little redundancy in the data in a well-designed OLTP database. And the purpose for OLTP really is business process data. You're looking at operational data, workflows, things like that. And the typical activity that you're going to find in an OLTP system will be inserts, updates, and delete. So that's different than an OLAP. An OLAP system really is an analytical processing database, and it's really designed for structured, redundant data. And the emphasis is on your ability to aggregate that data and to analyze the data. So it's different in an OLTP system it's different in an OLAP versus OLTP in that OLAP system really is emphasizing the ability to aggregate and analyze the data itself. The data is often denormalized, so you're going to find redundant data. You're going to find very large, wide, when I say wide, I mean a table that has many columns, a lot of data, many rows, and there could be redundancy. There are fewer tables, and those tables are larger. Typically, an OLAP system is something like a data warehouse, trending, historical, analytical, right? And an OLAP, the activity you're going to see most of the time is a writing and a reading. You're loading the data in, and then you're reading that data for your reporting. Most often, in an ETL, you're going to have both. You're going to have an OLTP system that you're selecting data from, transforming that data, and pushing it into some type of OLAP. Now, that's not always true. Not always true, but this really is kind of the essence of an ETL. It's really a matter of extracting the data from an OLTP system, transforming it, and then loading it into some type of OLAP, some type of reporting engine. And we usually handle this step-by-step process in some type of workflow or task or procedure. Right? It doesn't necessarily have to be OBIEE, for example. It could be something that you've written, or someone at your company has written the package to extract data, transform that data, and then load it into some type of OLAP system. So I've mentioned, we've talked about ETLs, and I've mentioned the ELT. An ELT is essentially pushing the transformation after the load. So you've got an ETL, which is an extraction transformation, and then loading, and then an ELT, which is an extraction, loading, and then transformation. And both of these, there are the concepts that we'll talk about today will apply. And with each one of these, they're going to be workflow, task, procedures that handle this activity and this work for you. So let's kind of step back a little bit, and let's talk about, with this concept of a source, a staging or transformation stage, and then a target. Let's talk about all of the pieces and parts, the components of an ETL. And I'm going to focus on ETL, but you really can, during the course of this presentation, you can kind of swap in your mind ETL, ELT. A lot of the things that we discuss are going to apply to both an ETL or an ELT. So ETL, your source data, it can be a lot of different things. You could have data in the cloud. You could have data wrapped up in some type of a CSV file or unstructured data, right? A NoSQL database. It's really a file system type database. There could be part of your ETL that actually the source is another data warehouse. There are ETLs, obviously, that have a portion of their source data in data warehouses, and then we commingle that. We grab data from a SQL Server database. We grab data from an Oracle OLTP EBS database, for example, combine that, transform that. And I just mentioned EBS. So yeah, an EBS database, which would be an OLTP system, a relational database. And then, of course, you might actually happen to have CSV files or flat files that, that are non-indexed, partially structured flat file data that you're pulling data in with some type of process. And then you're extracting that data from these source locations, and you're putting it into some type of transformation, right? You're loading lookup tables, you're loading temp tables, there are lookup files, there are a lot of different components and pieces and parts to a transformation stage. And then, of course, the final stage would be that target. that place where you're actually writing all your data to. And that final stage typically is an OLTP system. So you're loading up these large tables. Sometimes you're completely refreshing several tables with redundant data, with fresh data. So keep this in mind. We're going to kind of come back to this concept of these source target. But I want to talk a little bit about now, actually kind of dig a little deeper, if you will, even more so than what we've done. Let's just think about the components, because what I'm trying to do is I want to lay the groundwork and the foundation for us so that we understand when we go check and we're looking for bottlenecks, problems, slow areas in our ETL, what are the areas that we look? Well, if we think about the data, right? We've got data. If we start with the data itself is in some type of structure, right? It's some type of data model, whether that's an OLAP, OLTP, whether it's relational, non-relational. That data has a structure. And then, of course, on the application side, we have a code base. That could be JSPs, that could be Java application code, it could be .NET, there could be Perl scripts running. And so within the code base on the application side, and then the database on the data side, there are other items that, other components, right, layers that are in this that are related to your parameter settings for your database, all the parameters, the configuration of the web servers. There's all the setup information. And then, of course, all of this lives on some type of host server. It all lives on either a Windows server, AIX, Linux, Solaris. There's some type of server that this lives on. And then you have different concerns, right? For the database, you might be more concerned about your disk, your CPU, your RAM. The application side, you might be more concerned about CPU and RAM. There are different concepts that you apply to the server itself, and then different approaches and ideas to making sure that your ETL is healthy and functional and fast. With the operating system, you've got different architectures, right? Going beyond just the memory protection, just in simple ways, the operating system itself might approach file system fragmentation differently. There could be a difference between the way that your Sun Solaris operating system handles file systems versus your Windows. And there are definitely differences. All of these things come into play. Then, of course, the storage. What kind of storage? I mean, this is a whole other layer, right, of where the data. Well, we can go all the way back to the data and say this data is in a melt point on a SAN device, on a Sun Solaris system. There's all these different ways we can look at this. So the storage is important. We can't forget and just ignore that we have the data on a spinning disk or as an SSD. Then, of course, we have the network speeds. This could be a bottleneck. Our network speeds could be a problem, right? So these are the elements, the component layers that we need to really think about when we're looking at trying to find the bottlenecks, trying to find and tune the ETL. So we're trying to find areas and places where we can speed up the whole process. So let's kind of talk a little bit about this. Go back. We discussed some high-level concepts. I want you to keep these layers in mind, kind of step through all of these pieces and parts. So keep this in mind. And then let's go back to this other design, this source, transform, and target, each of these stages of an ETL. And let's talk about, just in general terms, high-level concepts here of where some problems and points of failure, and really we could say are challenges. Right? These are the areas where we find the most challenge. Network latency. Right? The network latency can be a real problem for us if we're not testing, if we have no idea. If we don't have any idea how fast the network speeds are, then we're connecting from one server to another. I mean, even in this design right here, right, we have all of these interconnected pieces and parts. If they are not connected to each other in a fast, if they don't have a broad speed, a fast speed between them, then they're going to be slow in transferring data to each other and communicating with each other. Our disk I/O. We can look at AWR reports for an Oracle database, for example, and we can see where our I/O problems are, where our disk problems are. But a lot of times we can't necessarily see where that disk I/O is from the mount point perspective. Are we reviewing those things from the mount point, the SAN device? Our disk I/O is important, and we have to be looking at that. Sometimes the ETLs themselves, the way that they're written, we're doing too much in memory. Sometimes, and actually I'll share a little thought here. I did this presentation in Collaborate just a month or so ago, and someone came up to me afterwards and asked me this question. They said, now you mentioned something about doing too much in memory, and there's a lot that we do today putting whole databases in memory. So it seems counterintuitive. It seems counterintuitive that you're telling me that I'm doing too much in memory, and that's a problem with an ETL. Well, it is if you think about the fact that with ETLs, if you're in the transformation stage, whether you're doing the ELT or ETL, the transformation stage, you're loading whole tables sometimes. You're trying to do merges. You're trying to do, you're dealing with gigabytes of data. And so if it's possible that your ETL is trying to do too much in memory, and that can be it can slow the whole ETL down. So you want to convert those into something like temp tables, right? Do something differently. Don't try to handle everything within memory. Your code could be a problem. Now, some of the other points of failure here is we look at the source, the transformation, the target, every layer here. Every component has code involved. How is that code written? Are there joins that are poor joins? Are you joining the right tables in the right way in order to reduce your record sets as quickly as possible? Right? You want to reduce as much as you can as soon as you can. Are there hints in your code? Now, we all have a love-hate relationship with hinting in the Oracle realm. Hints are great on some days, and hints are bad on other days. I think I have spent as much time adding hints to code as I have taking hints out because they cause problems. So definitely, when you see something like a parallel auto hint, you want to be careful with something like that. My first reaction would be to take it out, or to make it something more predictable, like a parallel 2, a parallel 4, or something that can be measured, right? So you want to look at your code. Code can be a problem. And with your memory, are you trying to do too much in memory with limited memory? You need to understand how much memory you have at each stage or at each layer of your ETL. And we need to make sure we have plenty of memory to handle all of the activity. The more memory you have, the more you can do. Your CPU bottlenecks. It can be I have seen a problem where certain portions of an ETL, like the transformation stage, trying to do all of the staging, all of the transformation in a virtual machine with limited CPU and limited RAM, and it slowed the whole process down. So the whole ETL was running 6 to 8 hours, and what we did in order to improve it was we made a change to one workflow, and we took the virtual machine out of the picture. We took all of the configuration, the database itself that was running on the virtual machine, and we put it on a physical server, with, I think, it was about twice to 3 times as much memory. And all of a sudden, the ETL now is running within 2 or 3 hours consistently. So you want to be careful. Now, I'm not suggesting that virtual machines are a bad idea. They're not a bad idea, but you have to make sure that you give the virtual machine enough resources to do what needs to be done. File system or cache fragmentation. File systems can become fragmented. And if you're working within Windows, the Windows servers sometimes will get fragmented. The file systems will become fragmented. So you want to be checking for file system fragmentation, and you want to be careful that that's not a problem. Now, it is true that Linux file systems can become fragmented, and I know that that's somewhat of an area of contention. Some people would argue that it doesn't happen. Some people would argue that it does. And I would say that for certain files can become fragmented. So you want to be looking for that. You can run an FSCK, and you can check for file system fragmentation. You're not going to see it as much in Windows as you would on a Windows server, but you will see it. Limited space. You want to make sure that you have plenty of room to handle everything that needs to be handled with the ETL. The logs, they will grow, and so you have to make sure that the logs will not cause failures. You want to make sure that you have plenty of temp space for your transformation, your staging tables. So those are just some high-level things to look at. And we're going to drill down a little deeper, and I'm going to show you how to check some of these things. So let's do this. Let's actually talk about some of these stages, and let's talk about some tuning ideas and some tips and some things that we found that might be helpful. So again, I'm going to probably relate some things that I've already related. I'm going to be a little redundant here because I think some of these principles are things that we've seen over and over. And so the more redundancy that I provide in my thoughts and my comments, hopefully the more that things will stick and things will relate to you. So the source often is an OLTP structured data, right? The traditional tuning applies. So what I mean is, if you're connecting to an EBS database and you are, that's an OLTP system, and you're writing queries to select data out of that EBS database, then if you've ever tuned a SQL statement for EBS or for a relational database, then all of the things that you've ever learned about tuning will apply. So take that knowledge and apply it to finding the bottlenecks and tuning the source. That might be the fastest, easiest place to start. You're probably going to already be familiar with tuning OLTP queries. So you want to also factor in your DML, or your data manipulation language. All of the inserts, updates, deletes, all of these things that are happening in your database, they can cause fragmentation. They can cause problems with your statistics on the tables and the indexes. Cardinality on these tables, on these indexes, is really important. And so when you're looking at your source tuning, you want to make sure that you're dealing with these things. And then finding poor plans and then tuning in a way that, as we've already discussed. So there's an approach that I apply when I'm looking at tuning OLTP systems and OLAP systems. The first thing I typically do is I will look at the SQL code, pull the code and see what the code is doing. Are there hints that can be removed or tested without them? Are the joins causing problems? Is there better filtering that we can do, right? Is there a way to reduce the amount of data that I'm selecting using the joins? Is there a way to reduce that data as much as possible, as soon as possible? And are there other things in the query? Are you doing implicit conversions? Are you converting to number? Are you using other functions and features that could disable the use of an index? If so, then you can look at like a function-based index. So the next thing I might look at would be statistics. I've kind of already mentioned a little bit of statistics here. You know, if you're dealing with a traditional OLTP system, an EBS database, for example, you got to factor in that the inserts, updates, deletes, factor in the stats, make sure that your statistics are up to date because the cardinality is very important when you're looking at plans. And then, of course, we look at the indexing, right? Maybe there are plans that don't have the proper indexing. Maybe there's a SQL statement that the indexing is not right. We've already kind of mentioned the function-based indexing. You definitely want to look at that. And then the table fragmentation. Conflicting sessions or processes during ETL. The two other things I typically look at. I might look at any other sessions that are happening or any other processes that are running during an ETL. And then finally, there's this idea too that if you're connecting to an EBS system, if that is a primary system that's being used all day, 24 hours, and you're selecting data against it, and you do find that there are sessions that conflict, that there are processes that are going on that slow down your selection from the data, from the EBS system, then maybe you want to look at replicating the tables that you're selecting from off to another database and then select from that. So create some type of isolated database that you can then select from. So looking at the SQL code, looking at the statistics, looking at the indexing or table fragmentation, the segmentation, if you will, looking at the conflicting sessions or processes during the ETL, this is what we call the 5S approach. SQL code, stats, space indexing, sessions, and schedule processes. If you were to apply this to a OLTP or OLAP tuning approach, then you can get to the root cause much quicker. So let's talk a little bit about the transformation stage. Transforming bottlenecks, all right? So depending on the ETL that you have, there could be a high percentage that's actually happening in memory on the server. So you want to watch your CPU, watch your memory consumption during the ETL itself. Make sure that your memory and your temp space is not being consumed. You know, the more you have, the better. And file systems, the file system lookups can be slowed. There are systems, you know, Informatica, for example, where we might have lookups, where all of the lookups as part of that staging transformation process might be in a file system. So we want to be careful in using a lot of those because there's no indexing. There's no indexing on a file system lookup. So you've got to get that into a database so that it will be much faster. And then, of course, file systems can become fragmented. So if we were to then apply the 5S approach to looking at the transformation stage, the first thing I would do would be to look at in-memory merges and joins, right? Anything that's happening within the code that could consume or slow the process down. The statistics can hinder on temporary tables. When we're dealing with staging and transforming and we're putting things into temporary tables, we want dynamic sampling. We don't want the statement to be looking at some type of statistics that are old, that do not really relate to what's in the table during runtime. So drop all the tables drop all the stats on your temporary tables. You don't need those. Indexing. You want to make sure that you're dropping all of your indexes prior to doing any loading. That can slow down the process. Lack of proper temp space could cause failure. So this is something to watch for. Look at your logs. Watch your file system to make sure that your logs are being backed up. Remove them and look for your, monitor the ASM. ASM, with ASM, you still can run out of space. And again, file system lookups perform better if they're converted to the database table lookups. So those are some ideas for your staging. Let's look at the loading or the final destination here, our target system. OLAP write speeds are really important. We need to make sure, so when we're loading, we're not as concerned about our read speeds. So we want to make sure that our write speeds are as fast as possible. Now the read speeds are definitely important because when we get ready to do the reporting, we're going to be reading for the database. So we want to make sure we're just paying attention to the I/O capabilities of the data where it lives. Indexing and statistics can be problematic. And loading look and see that the loading is happening as a bulk load instead of some type of loop. So again, if we were to apply the 5S approach, let's just look at some other ideas for the target bottlenecks. Make sure you're using something like a hint. Now, I've already mentioned kind of the love-hate relationship with hinting, and some of these are good and some of these are bad. But if you use the append or append values hint, it's going to be very helpful for you. The insert and updates can benefit from parallel hinting, right? So, but be careful with how much you're using hint because they can become problems. Your stats and your indexing added after the loads can be performed in parallel. Split the tasks out and try to do as much as you can as quickly as you can. Confirm asynchronous IO settings in your operating system and in your database. I'm going to show you how to do that in just a minute here. Use bulk loading wherever possible. I'm going to speed up the pace a little bit, and I want to talk about some common problems and fails that I've seen. But first, I want to ask you, what are the things that we want from our ETL or our ELT? Well, we know we want them to be fast, right? But it's not just making them fast. We also want something else. We want consistency. We want the ETLs to be as consistent as possible. So we want them to be fast, but we also want them to be consistent so that they're dependable, right? We don't want them to run 2 hours one day and 4 hours the next day. Sometime within 30 minutes or less than an hour, differentiation between each day is probably okay. So let's talk about some of the problems that we've seen very quickly. I want to get through this because I have some specific things I want to show you and how to check some of your settings. You know, if you're doing too much in memory, we'll want to be careful. You can consume all your memory. You can be selecting gigabytes of data, trying to do too much. Be careful that you're doing too much in memory. Be careful that you're doing too much from the file system. Be careful that you're trying to read against a bunch of lookup files that have no indexes or that could be fragmented. Look at your network speeds. Look at your drive speeds. These things go unchecked. Oftentimes, the network speeds will change and fluctuate throughout the day. You know, monitor them during an ETL and see what your network speeds are in the evening. Make sure that you're not being throttled back. Make sure that you're also looking at other system or session conflicts. Is someone else on the particular server, you know, doing something, running reports that they shouldn't be running at that time? Make sure that you're using the asynchronous features in your operating system and your database correctly. You know, if you're not looking at these things in the proper way, then they might actually even be turned off. Take advantage of partitioning wherever you can. And then go back and make changes to your code to select only against the partitions that you need data from. Make sure that you're providing enough resources to the database for it to do its activity, whether that's CPU, memory, or space. Make sure that you're looking at the workflow logs, right? If you're not looking at what's happening during the ETL, whether that's live monitoring or whether that's going back and looking at the logs themselves, then you have no understanding of the real activity of what's going on. So you have to review that. And then, you know, you can look at the logs, but if you don't understand the business purpose of the data, you might not understand why the certain SQL statements are doing what they're doing. If you wanted to introduce partitioning and then you wanted to reduce the selection of data by using some type of partition pruning, if you don't understand the purpose of the data, there's no way you can accomplish that. So you need to understand why the task that's written in the particular ETL is doing what it's doing. And then again, using hints too much or doing them wrongly. Some of the ones that I've seen the most that are used wrong are ordered, cardinality, and parallel. These three, the first thing I do is take them out. I test to see if it performs better without the hint, and then I put them back in if it doesn't. You know, so be careful how you're using hints. So very quickly, checking asynchronous IO database settings. If you're using Oracle, keep in mind the ASM, it bypasses the file system. So this setting might not necessarily be applicable to you, but there's a setting called disk asynchronous IO, and it's a true or false setting. So you can do like a open up SQL Plus, show parameter disk asynchronous IO, and it's going to show you whether you've got that turned on or off. Then there's another asynchronous setting called file system IO options, and there are 4 settings for this one. Most often, I've seen async, the first option here, and then I've seen direct IO as the second one. But the recommendation actually would be to use set all. That way you're getting direct IO and asynchronous IO. So make sure that you've got that set to set all. And then if you want to check, maybe you already have this enabled. Maybe this is already running. If you're in Linux, you can just cat out /info, grep your KIO, and if you have it enabled, then what you're going to see is you're going to see these asynchronous numbers, the activity, when you grep that out. If it's not enabled, or if it's disabled, then you're going to see zeros like this, okay? So that's one thing to look for. See if you've got it set up. Now, if you're running AIX is going to work a little differently. You can check this in AIX without any problem. Use iostat-a, and you're looking for the average, the max, and the max requests right here. So this is your IO, and you can see here this is 0. All right, so look and see if you have this enabled in your AIX systems. Having this enabled in the system is typically it's turned off. If you're in Linux, Sun, Solaris, AIX, typically it is turned off. So you want to make sure that you turn it on. Otherwise, the settings that you make in the database really don't apply. Some of the other things that might be helpful would be huge pages in Linux or large pages in AIX. And to verify whether or not you're using these huge pages, you can grep out, again, your memory info and look for huge pages. You can see here that we've got some settings in this particular file, this file system that I'm checking. And this enables you to take better advantage of memory paging within the server itself. And in AIX, you're going to approach it differently. You're actually, if you get the process ID, and you see here I'm looking for the use of pmon to do the process, and you can see here the memory, I'm using svmon-p with the process ID. And what you're looking for is the page size. Okay, so AIX refers to this as large pages, and so they're large pages set to 16 megs on this server. Now, if you will, notice there is a meta-link note ID. When you're dealing with AIX and large pages, I would suggest taking a look at this note ID, get the slides, or take a screenshot of this and review that note ID. There are some comments that they make on how to size your large pages adequately and what your settings ought to be for whatever database version that you're running. So that's AIX and Linux, huge pages, large pages. One of the other things that we've mentioned is checking your network speeds, right? Look for network latency. Now you could do a simple ping, and your ping is going to respond, and it's going to give you some basic times. But the basic times that you're going to get might not be as helpful as using something like Netcat. Netcat is a tool that you can get for free, but I actually like to use iPerf, and this will give you your network performance. So there's always an A side and a B side. Okay, so let's say that on the A side, you're setting up your client settings. If you can read that, you're starting a listener, iPerf-C with an IP address -D. So you start the listener on the A side, and then on the B side, you're connecting to the other server. You're doing iPerf-S. You can connect to that, and then you're going to get your back and forth responses from between A and B and be able to measure. In this particular example, we're transferring 73 megs, and it's about 61 megabits per second. So pretty good network speed between these two tests. So when you're monitoring ETLs, we have about 10, 12 minutes left, and I want to leave enough time for questions. So if you're monitoring your ETL, which you have to do this, you have to monitor the ETLs from beginning to end. And what I will do is I will open up all my tools across 2 screens, and then I will take screenshots throughout the process, and that gives me all of these tools and these views with a timestamp of the screenshot. So what I'm showing right here is a crop screenshot of SQL Developer. Oracle SQL Developer is free. There is a feature in that database that allows you to monitor sessions. If you go to the top, go to Tools, select Monitor Sessions, it's going to ask what database you want to connect to. You select that database, and then it gives you the output, and you can actually see what modules you're connecting to. You can see here that I'm connecting to an OBIE process. This is Informatica, and I'm monitoring these processes. And I can also select a SQL ID. I can see the activity, the explain plan. I can actually get the execution plan. So there's a difference here, right? If I were to take this, potentially, this SQL ID, go back tomorrow, pull the explain plan by just doing explain plan 4 or using Toad, I might or might not get the actual execution plan. But if I'm monitoring this right now during this process, I can see the execution plan at the bottom down here. You can also see the other tabs. You can monitor the weights. You can see the server, the client, the application, any contention that's going on for these statements. You know, we mentioned monitoring scheduled processes or conflicting sessions. You'd find that here if you're monitoring using this tool. And then, of course, the long operations. With these long ops, you can see exactly at the block level what's going on down here. So I mentioned long operations. Now, you can actually, what I'll do, I do this, I monitor the $$ session long ops directly. And there's a way, I have a couple of scripts that I run, and you know what you're looking at is the long operations. And it's not always true, but it's mostly true that when you talk about long operations, you're talking about slow reads. You're talking about block by block reads, right? If you can look here, this table scan, this OBAW, here we're reading from a data warehouse, and we're reading so many 166,000 blocks out of 166,000 blocks. So there's activity going on here, and it's very slow. So this gives me a little insight into not only where it is, but what it's doing. I can make note of the tables that it's touching, and I can go back and I can take a look and see if there's a way that I can improve the execution plan to deal with those tables in a better way. Most everyone's probably familiar with PuTTY and Top. PuTTY is a great tool, and again, this is one that I open. I'll pull Top over, and I'll monitor all the activities. I'll usually grep out the Oracle user, and that way I can see the Java activity. I can see OBIE. I can see Informatica. I can see anything using that Oracle account that's going on top, and I can monitor that. So you got to be monitoring this, and you've got to be looking at the activity. So we mentioned drive speeds, and we mentioned, perhaps the data or the servers that you have, the mount points themselves, live on some type of SAN or storage device. How do you know that? Well, you could use a tool like DF. DF will show you your mount points, and you can use DF-GH. You can do DF-M for megabytes, DF-K for kilobytes. Depending on the size, I'm using DF-GH. That gives me my gigabyte size. And so you can see here I have several mount points, and you can see that it's telling me not only the size, but it's showing me availability. It's showing how full the capacity, what's the remaining capacity on these, and then of course where these are mounted, right? These all could be mounted on a SAN device somewhere. You know, there could be, the slowness might not, it might be from the, might appear to be IO related on the particular server I'm on, but it might actually be that mount point lives on some type of SAN device, on another server across the network, right? So we've got to pay attention to those things and root out these problems and understand how everything's configured. So how do we know if it's a drive speed problem? We can measure that. We can use HDParm. You've got to have sudo or root to check this, but if you do an HDParm-T, and you notice I have a /dev/SDA, that's my mount point that I found in the previous exercise of using the df-gh, that I can check the time the buffer reads. Shows me 34 megs per second. I can look at the direct IO, --direct. All right, or HDParm, I could look at the cache reads. How quickly is it reading from the cache for that particular device? Now, in this particular example, this disk was mounted, spinning disk on the server. But you could do the same thing for your SAN devices. Some of the other tools that I've used in the past that I really, really like, it's a product called DVTimeMonitor, written by a developer named Dominic Giles. And Dominic has this great tool that you can configure multiple databases, multiple servers, and you can see here I've got an EBS database host, I've got an OBIE database host, and then of course I'm monitoring the DAC. And you can see in this screenshot, the CPU is it's through the roof on the DAC server. And so this gives me my CPU, it gives me the IO, and I can see that activity live. And again, I take screenshots. I arrange all of these windows during the monitoring process, and I'll take screenshots of the activity. Here's another one that I use that shows some of the top 10 wait events. And all of this is customizable, and it's free. You can go to dominicgiles.com and download his tools. Now, he's got another one called DVTimeMonitor that allows you to add your own queries. So what I've got here, this is a screenshot of 3 of these side by side. If I zoom in a little bit, you can kind of see a little better the details of what I'm monitoring. So you can see the IO request at the top, the IOPS or CPU, user commits, the redo. Redo is very important. You can skip all of the redo activity of your inserts if you use something like an append, a hint, or append values, depending on what your SQL statement is doing. So DominicGiles.com is a great product. I don't know him. It just happened to be one that I found a few years ago, and I just use it a lot. I really like it. So if you're using Oracle and you're using OBIE, then you're familiar with the DAC. Let me talk a little bit about the DAC, and then we can wrap this up. The DAC really is, it's a metadata-driven admin tool. And it allows you to deploy your tasks, to manage your tasks. You have application configurations that you can manage with the DAC. And then you can actually execute your ETL loads right from the DAC. Now, the thing that I use it for is monitoring. And you can see here a small screenshot of an activity where you've got your execution plans, and you can see the activity of that plan right here. This is one that's running. I've got the process ID. I can see that it's 93% completed. And then at the bottom, I can actually see the tasks that are running. And so again, if I have all of these spread out on my 2 monitors and I do a screenshot, then I can see what's running in the DAC. I can see the CPU consumption, or the IO on the Informatica server or the EBS server. I can see the top Oracle accounts running, in PuTTY and top. I can see all of this in one view. Now, the nice thing about the DAC is it does save your run times. So then you can come back after the ETL has completed, go to your task tabs, and then I'll sort all of those tasks by the duration. And then I'll find the longest running tasks. And then what you can do then, find those long-running tasks, go back to Informatica or go to your workflow logs, pull those tasks up and extract the SQL, take a look at the SQL and see what the SQL statements are doing, try to understand the performance problems. Maybe there's some ways that you can spend a little time doing some tuning and improve the speeds of these. So that's the DAC. So we've talked a little bit about OLTP and OLAP and really what the differences are in their tuning, and how to tune those, and how they're different. We've talked about all of the layers and the components of ETLs or ELTs. We've talked about the different pieces and parts and where they can fail. Each one of these component parts and failures. We talked a little bit about all the tuning points, and I've tried to kind of give you some very high level ideas and concepts that might apply. And then some things that we found that, some common fails or misconceptions that people are applying. And then hopefully some suggestions on how to make those things easier. So there is a survey here we'd like to encourage you to take. And I think that's it. Stephen, I'd like to turn it over to you, and we can take questions, and we can spend the last few minutes discussing any other items that anyone might have a question about.
Absolutely. Thank you for that great presentation, Chuck. And we'd appreciate everyone listening in today and viewing just to take a moment, fill out that survey that popped up. Moving on to our first question today, what is your main challenge in running ETLs?
So there are a lot of challenges. We've kind of talked about some of these, and I think some of the challenges are not only the technical. We can't forget the fact that there are those above us, those in leadership, that might or might not understand the ins and outs of the ETL process. They have demands that their reports are available right now. And so part of the challenges are, really getting the ETLs to run as quickly as we can, but also consistently, so that there's not something new introduced into the ETL that would cause it to run 3 hours longer, go into the workday, and then affect everyone's reporting. There's always month-end type activities. There are a lot of challenges related to the users and people who actually need that data. So to me, when I think about beyond the bottlenecks, beyond the slow points and things that we've already discussed, I think it's working with the leadership, it's understanding the business process, and a lot of times we have DBAs that are highly capable, very functional, and yet they don't understand the business process and the purpose. There are a lot of ETLs that I've looked at, and I don't understand, why they need this report or why this SQL statement is doing what it's doing. And so you have to communicate with those who own the data. So I think there are a lot of challenges, not just from the technical side, but from the business side. And they all have to work together to understand and improve the quality of the ETLs.
Understood. So to a certain extent, it's a team effort.
Yeah, absolutely. And I think it's continually a team effort. They do evolve, they do change as business needs change. So yeah, it probably will always be a team effort.
Understood. Our next question, Chuck, can ETL be used to replicate a live OLTP database with 5 million transactions with near real-time replication?
Near real-time, 5 million? Well, if you're talking about an Oracle database and some of the processes that I've seen, 5 million rows is not a lot. So I think so. I think it could be done. I think you'd have to take a look at the parameters and see how everything is configured. I think you have to isolate some of the activity so that you don't have interference. But if you could build it in such a way that you could isolate it, then I think that again, there's a question here about near real time. So, within 15 minutes, within 30 minutes, I think it probably could be done. I think how quickly can you run that process? I think probably would be the question. I do believe that OLTP systems can be very fast. They can be very fast if they're tuned and if they're performing well.
Understood. Moving on to our next question, when you were talking about DAC, we had a question come in. Are all the features in the default, or are they in separate licenses?
All the features. I'm not sure I understand that question. I believe,
okay.
But I'll hazard a guess. So when you have the DAC itself, the features that you get with the DAC come with the DAC. So if you're using OBIEE and you have this administration console, then all of the features that I showed today, they're just part and parcel of the product itself. That's just the way it works. So there's not an additional license to get the monitoring, to get the recording of all of the task times and the administration of the components. All of that should be part of the product itself.
Understood. And we have time for just about one more question today. Will the ideas and concepts apply to my ETL or ELT if I'm not using Oracle as the primary database? We have SQL Server ETLs that run in the evening.
Yeah, so all of the concepts that I've presented today, the concepts will apply to a SQL Server, MySQL, an OLTP to OLAP type ETL process or ELT process. Now, there are some things clearly that are very specific to Linux, for example, or very specific to AIX that might or might not apply depending on what components and what servers you might have involved in the different stages. But SQL Server is an OLTP, can be an OLTP database, it can be an OLAP database. So if you're running ETLs using SQL Server, then much of what I've presented today can apply.
Understood. That's all the time we have for questions today. We apologize that we were unable to get to all your questions, but as I mentioned earlier, all questions will be answered via email. I'd like to thank our speaker today, Chuck Ezell, Performance Tuning and Optimization Services at DataVale. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived. Plus, you will receive an email tomorrow notifying you when the archive is posted. And as we stated earlier, just for participating in today's event, someone would win a $100 American Express gift card. And the winner today is Mike Reeser. Mike, we will be in touch via email so you can claim your prize. Thank you, everyone, for joining us today, and we hope to see you again soon.